Welcome to Lesson 22, Heuristic Evaluation. By the end of this lecture, you'll be able to argue for conducting analytic evaluations, explain how to conduct a heuristic evaluation, and identify problems in an interface when given one of Nielson's heuristics. So let's place heuristic evaluation in the framework of evaluation techniques. Last class, we talked about an analytical method known as modeling, when we use these models to be able to predict how people would perform in an interface. Now, modeling techniques are good when we can accept assumptions and limitations. For example, we have to know how the system works and know whether it's an expert using it. But if we can't accept these and we don't want to run a full user study, what do we do instead? Well, that's what we'll cover today, which is an analytical method that involves asking experts. This is an example of discount usability. We ask 3 to 5 usability experts to inspect our system to identify as many problems as possible. And one way of doing this is a heuristic evaluation. An expert evaluates the user interface using guidelines. A usability inspection method depends on the evaluator's judgment. HE is a discount usability engineering method, and one case study found the factor of 48 in cost benefit. So the cost of an inspection was about $10,000, and the benefit was $500,000 in savings for design and development down the line. This is a handy little fact to justify user-centered design, so keep it in mind as you go forward and think about using these design methods in creating effective interfaces and systems. So how do you conduct a heuristic evaluation? Well, you conduct a systematic inspection of a system. You want multiple evaluators, that's way better, and you want trained evaluators if possible, that's way better. And what you get is increasingly more errors found, 22% for a single systematic inspection of a system, 41% for multiple evaluators, and 60% for trained evaluators. They go through the entire interface, the whole interface, and the result is a list of problems, guidelines violated, and proposed fixes. So how many evaluators should you recruit? Well, work by Nielson shows that as you increase the number of evaluators, you catch more errors, but it starts to plateau, it reaches a bit of an asymptote. And you have a reduction in the benefits to cost, because as you increase the experts, your cost increased, but your benefits are starting to decrease. And so Nielson suggests that 4 might be optional. And that gets you, about 70% of errors, but also keeps the cost benefit pretty high. So we're going to go through the heuristic evaluation methodology. The reference is Nielson's How to Conduct a Heuristic Evaluation. At this link, take a look at this, especially as you go through your heuristic evaluation assignment. Each evaluator inspects the interface separately, and it's okay for the designer to answer the evaluator's questions. They're an expert, they're going to weigh all these things in their opinion. And you go through the interface several times using the heuristics. You can also supply evaluators with scenarios of user tasks. And what you do is you provide a set of heuristics. We'll go through Nielson's modified heuristics. These ones have been evaluated and refined over the years. The first one is visibility of system status. You've got match between the system and the real world, user control and freedom, consistency and standards, error prevention, recognition rather than recall, flexibility and efficiency of use, aesthetic and minimalist design, help users recognize, diagnose, and recover from errors, and help and documentation. Do any of these look familiar to you? Many of these are tied to the interaction design principles that we've discussed in the class, and from some of the outcomes from our discussion of cognitive properties and of human capabilities. So they're all grounded in the literature and the work that we've already looked at, and this kind of ties them together in a systematic way to do an effective evaluation of a system. Let's go through each of Nielson's heuristics in a little more depth. The first one is visibility of system status. You want to keep users informed about what is going on, what page they're on, what part of the process. And you want to provide appropriate feedback about what the system is doing and how input is being interpreted. So for example, you want to have a confirmation at the end saying, yes, your password has been emailed once you've signed in or you've forgotten your password. Or if something was unsuccessful, you have that visibility that the system did not install the whatever you wanted to install. The second heuristic is match between the system and the real world. You want to use common words and not techno jargon. You want to have error messages and feedback that refer to user objects, things that the user and other people involved in the system will understand. You want to allow for full-length names. So for example, you want to say things like hit any key to continue, and you want that full text to allow people to understand what it means. Oh, any key? Okay, I press any key. So some examples might be, this one on the left where you've got a terminal terminal interface, and you have a bunch of this really jargony, difficult to understand feedback. This might be useful if you're, an expert diagnosing the system. Usually you can access a screen like this. But the one on the right is a lot more, has a lot more match with the real world. It says that there's an error writing to the printer. It gives an example, a full name of the printer. It says it's out of paper and you need to add more paper. And then to continue printing, click retry. So it's got all of this extra information explained quite clearly and related to the real world. The third heuristic is user control and freedom. You want things to be easy to abort. You want to have cancel buttons, things like that. You want to be able to cancel an order, cancel changing a profile. If you're in a screen that you don't want to be in, you want to be able to get out of that. You want to have things be easy to undo. This is often an issue with modern websites. What does the back button do? And many sites can get confused if you use the back button because they're doing all of its own asynchronous management of the state. And when you press the back button, you maybe send a form again or do some sort of update to the system that doesn't do what you want to do. And you have to keep in mind that users, even experts, will make errors. We need to design our system to either prevent those errors or allow easy recovery of them. So there's no way to get out of editing a text field. Then you're stuck in there. You have to put something in there. That's a problem. The fourth heuristic is consistency and standards. You want to have the same command always have the same effect. You want to have locations for information, names of commands, to give the user a mental model of the system. Consider things like size, location, color, wording, function, sequencing, etc. in some of the ways that we've described for visual feedback, right? And following standards can really help. If you follow existing standards, then it will be standardized. It will follow what other systems are doing. So for the web, you might want to use templates or CSS style guidelines to make sure everything is relatively consistent. So for example, this weather interface right here is a violation. If you swipe to the right, it changes the day if you go slow and changes the city if you go a bit faster. Sure, this offers a bit of control, but there's no way that would map to a mental model for me, right? I would imagine if you go slowly and it changes the day and you go quickly, maybe it'd do a week or maybe it'd do several days or start to roll and have momentum in a physical rendering somehow. But to actually change what it's scrolling between depending on the speed doesn't make sense. It's not consistent. The fifth heuristic is error prevention. Here you want to focus on selection rather than entry whenever it makes sense to do so. You want to remove or gray out illegal choices, but this can be uncommon for web pages. Autofill and confirmation asks are really valuable here to make sure that you're getting something that makes sense. If you're in a banking application and you are trying to send an e-transfer for $100,000, they might say, "Are you sure you meant that? Did you miss a decimal point or put too many zeros in there?" And if you are trying to transfer that much money, you probably don't need to do it that often. At least I sure don't. So that way you can do these kinds of checks to make sure that some catastrophic error is avoided. You also want to avoid modes, which is when the same user action has different results. So for example, draw versus erase. In a powerful tool like Photoshop, you might need these different tools, these different modes. And so what they do is, because you have all these different modes of editing, you make them visible. You have a tool panel, you can edit between those, and you always know what's happening. And that's reflected in the cursor. You'll have a brush or a circle for that. You'll maybe change the icon of the cursor. So at least you're giving extra feedback about what mode you're in. But if you can avoid modes altogether, then people don't have to remember what state the system is in. So for example, Expedia and Amazon ask when the user enters an ambiguous city. If you say you want to fly to Columbus, you have several different Columbuses that you can go to, or you can even enter the airport lookout. And so all of these give the state name alongside the city and give the airport code, which makes it a lot easier to be like, okay, which of these did I actually mean?